Alright, so this is lesson 3 in the lightning strike series, and in this one we're going to take a look at how to emit particles from our lightning. So we have 3 particle systems that we need to generate. Like the first one will be when it hits the ground. So we'll have like basic particles bouncing off when the lightning hits the ground. The second is particles coming off from the lightning itself. And then lastly, we need particles coming off from our rigid body. So the debris particles that will happen once these pieces sort of explode. So the first one we'll start off is the sparks when the lightning hits the ground. And what we're going to do is we're going to take it from here, like these basic particles that we have. This is where it's going to happen. Okay, except what I want is I just want the particles that hit the ground. So take a blast here and just set it to points, and we'll set this to hit and do delete non-selected. So yeah, so you have like these guys sort of just bouncing around. So they're sort of coming on and off because it's just picking it up when it hits the ground, which is fine. If you want it like all the time, then what you can do is, like once it hits the ground, I just want the particles to be there. We'll have to make some small changes into our base emission. So just come into the pop solver and make sure that you have all the attributes. So yeah, so it has all the attributes, which is fine. So what you'll do is, there is something called as, if you look for the attributes, there'll be something called as total hit. Yeah, there you go. It's called hit total. So what we want to do is we'll say that's like a counter, like how many times has it hit the ground or whatever. Like it's counting the number of bounces or whatever. So we can just say like hit total is more than 0, which is that means that it's hit it once, and that is the group that we want. So you can just create a group expression, or we can even try to do it in the blast. Okay. I can just do, what is it called? It's called hit total, right? Yeah, okay. So we can just do at hit total greater than 0. And let's see if this works. Okay, so do delete non-selected, and there we go, see. So now we have these particles that have now hit the ground. Okay, so let's just call them as hit. Okay, and now we can take another pop network. Now the thing that happens is if we use particles to emit more particles, like in a separate pop network, then it picks up the attributes that this pop network has, or these particles have. So the problem that happens primarily is with age. So if these particles have a certain amount of age, then the new particles automatically just pick that up, and you can't override it, or it's very difficult. So the best thing is just get rid of it. Okay, so take a delete attribute, and we can get rid of the stuff that we don't want. Okay, so what we want is we just want to keep velocity, and everything else we can get rid of. Okay, so I can just do a star here, and we'll do uptick V. So we're just keeping velocity. Like if we press I here, see, now we just have velocity. Okay, and I can also take a group, and we can take a group delete, and we can get rid of everything. So just press in star over here. So this is fine. Now let's just pick up the pop network, and they hit the ground on 8. So we can say pop network starts at frame 7. Okay, because why waste time, right? Okay, so if we jump in here and press play, we should we won't see anything, because by default the emission happens from surface, and we want it to happen from points. Okay, so keep it to points, press play, and there you go, we'll get that. Okay, which is looking really stupid. So we want to make a few changes. First of all, get like a static, get a ground plane. Don't get a static solver, just get a ground plane. We'll merge these together. Second is we want to add some velocity to this. So let's do add inherited velocity. We'll lower the amount. I'll just keep the y a little higher, or actually no, let's just keep it to 0.6, which is fine. And then take a pop force because we want to add some gravity. So just take this and we'll make it minus 9.8, or let's do one thing, let's make it minus 3. We'll just keep it very random. Okay, and if I press play, yeah, there we go. So let's turn off the ground plane, or at least like just turn off display proxy geometry. So see, there you go. So we're getting this. Let's see the difference if we just keep it to hit, right? Like we have this, instead of this, if I just take a blast here, and if I just pick up hit and delete non-selected, so we just have like, you know, these guys. Let's just see what kind of a difference you get. Yeah, actually this isn't bad. Yeah, no need to do the hit total. I think this is good. Okay, so we want to do a few things. First of all, in the ground plane, come into physical, like lower the bounce and the bounce forward. Let's take the y velocity and make it like 2, so it bounces a little more. Yeah, there we go. Yeah, perfect. This is great. So what we're getting is, you know, like they don't spin too much. Perfect. This is nice. Okay, and what we lastly want to do is get the lifespan to around 1 with a little bit of variation. So yeah, I think this is good. Okay, so we want to do a few things here, which is I just want to color it and give it some like fade it out over time. Let's give it a little more life, maybe 1.5. Yeah. Okay, so the first thing we want to do is take a blast and just bring out the particles. So we'll keep it to points, stream first input, delete non-selected. Okay. Now we wanted to fade out based on its age, or based on the normalized age. So what you want to do is you have to calculate the normalized age. Sadly, there's no there's no attribute for it. So what you want to do is you just actually there's like a internal attribute which you can't access directly. It's called n age, which is normalized age, but it doesn't, like, you can't really access it in any particular way. So what you want to do is just create f at, we'll call it new age. Okay, and this will be age divided by life. So essentially what you're doing is you're taking the total age of your particle divided by like the lifespan. So it gives you like a normalized value between 0 to 1. Okay, and what this will do is if I take a color node and I set it to ramp from attribute and I pick up new age, and you'll get this, see. Okay, we can like flip it and you'll see that happening. Okay, so we can just color it a little bit. Like I can probably make it like a bright blue or something like that. Yeah, there we go. So that looks nice. And then I can do the same thing with the alpha. So just take a point node and let me just see if I can do it through a float. So take an attribute and just float, because you can get a remap in there, you know, that will be easier. And set this to alpha. The A is capital, so alpha, and we'll say set always, set it to remap attribute, and the attribute we want to remap is new age. Yeah, and what that should do is, okay, flip it. Yeah, there you go. See, so it fades out. Like if I bypass the color, does it fade? Yeah, it fades. There you go. See, so this is nice. Like if I want, I can like lower the opacity to like a fair bit, or don't lower that. You can lower the max value here, like a lot. Yeah. See, So we get like a decent result out of it. Yeah, if we want, we can come into the popnet and I can, increase this a little bit so it bounces a little more. Yeah, I think this is good. Okay, so these are our first set of particles. I can put a null here and we'll call it sparks. Okay, so the next set of particles we want are from the lightning itself. From these guys, like the curve here. Yeah. So I want particles from this. So not from the geometry, just from the curves is fine. So I can just take a null and let's just drag it out. Okay. The first thing is we'll just generate some velocity from this. So I'll just take a velocity. You'll get a node called point velocity. So just bring that in and we'll increase the frame samples a little bit and keep it to compute from deformation, which is fine. And we can also, no, I think this is okay. This is fine. Okay. Does it have attributes? Yeah, it doesn't really have much. Okay, so this is fine. So let's see if we can use this to, generate particles. So take a pop network again. And so this will start at what frame is this coming in? Let's start at frame 2. Okay, so we're getting something. So let's just jump in, we'll make a few changes. First of all, again, need a ground plane. Even though we're not going to hit it, it's not going to last long enough to hit the ground. But we'll just keep it there anyways. Yeah, let's turn this off. And let's take a pop force. Make it -3. Let's call this gravity. Okay, so a few things I want to do. First of all, let's add some velocity to this. Secondly, I want only about 50 particles per second. And we'll bring down the lifespan to around 0.5. Let's see what we get. Yeah, that's not bad. Let's turn off the guide. The lifespan I want even lesser, but let's also give it some noise. What if we don't have gravity? Let's just see what we get. No, I think a little bit of gravity will be fine. Let's make it -1. Okay, now one thing I can do is you have some of them which sort of just zoom off, really fast. So you can take a pop kill and we can get rid of anything that is too fast. Okay, so I can just come in here, I can enable this and let's just say we can calculate the speed. So we'll say we'll just say length of at v, which is the speed, is greater than 0.4. Let's see what we get. See, so you're killing off all the really fast particles. That's a bit too much. Let's do more than 1. Yeah, so those fast ones that were kind of zooming off, those die out. Okay. And I can just increase this. Let's try 500. Yeah, I think this is fine. And so what I can do is, again, do the same stuff. We can come up here and I can just copy all of this, so let's just take this. Actually, let's do one thing. Let's just bring this down and let's do Control-C, Control-V for one of them. Okay. And let's merge these together, after the blast. Yeah, so what we'll get is, okay, we are getting this because it's causing some issues. What you can do to make sure that doesn't happen is we can do a bit of a switch. So take a switch node here and we this one starts at frame 2. So we switch at frame 2. Okay, so we just do an alt click here, come to frame 2 and it switches to 1. Okay, so we won't get anything in the beginning. And we'll have to do the same thing here as well. So with this pop network, which is this starts at frame 7. So we'll do the same thing. So do Control C, Control V, or actually it doesn't matter. We can take the same one. So just take a switch, and the null will be first, and frame 7 is when we switch. So alt click at frame 6, and at frame 7 it jumps in. Okay, so that should be good enough. Yeah, see, so now there's nothing in the beginning. Yeah, so let's merge these two together and see what we get. Yeah, so if we press play, see, let's come to geometry, and I'll just lower the point size. Yeah, this is nice. Okay, now one thing I can try, which I wasn't thinking of at that point in time, but in the particle network, I can try to use this debris, or this, like the broken ground, as collision. Let's see if we can do that. So let's take a null here, and we'll call it out ground, and let's see if we can use this. So I can come into the particle network here and take a static object, and we can pick up the out ground, and we will merge these together. And again here I just want to sort of, lower both these things. Okay, we'll have to make a few changes. So use deforming geometry, that's important. Okay, so the reason it wasn't showing up is because I was trying to bring it in from the cache. Don't bring it in from the cache, directly bring it in from the rigid body solver. Okay, so where is my particle network? Yeah, there it is. Okay, and let's just press play and see what we get. Yeah, there you go. So yeah, so what it's doing is it's a little more, interesting now, because it's actually hitting, the ground as well. Yeah, that looks pretty cool. So if we look at it in the final version, this should be a little more interesting. See, so they're actually bouncing off those pieces. Okay, so that's as far as the basic particles are concerned. So the next lesson, we'll take a look at how to do the debris from the rigid body solver.